So this is 3 terminal MOSFETs. So basically here we have the source, drain and gate, and we have 8 terminal MOSFETs as you can see. So for example, to identify the first pin, we have this dot here. Do you see this white dot? Means this is the pin number 1, pin number 2, pin number 3. So these 3 pins are source. The pin number 4 is gate, and the 4 other pins are drain. So as you can see here in the schematic, do you see here we have pin number 1, 2 and 3. So these 3 pins are connected together. So this is the source. Do you see S? And here we have the 4th pin is gate. So the gate always is connected to an IC, a control IC. So 3 pins for source, the 4th pin is for gate, and the other 4 pins are for drain. We can even check the MOSFET using the multimeter. So to check the MOSFET using the multimeter, we should always select the diode option. Okay, the diode option, as you can see. Why? Because simply the MOSFET contain diode inside it. As you can see, this is MOSFET. Here we have the diode. Do you see the diode between drain and source? Let's take this MOSFET. Do you see the white dot here? Means this is the pin number 1. Means this pin number 1, 2, 3 are source. We should find a continuity here. So let's check. I will put one probe here in the pin number 1 and the other probe in the pin number 2. We get a continuity in the multimeter and a bezel. So let's check the other pin. The 3rd one, we get a continuity. So the 4th one, nothing in the multimeter. We didn't get a continuity because this is the gate. So these 3 pins are connected together. So this is source. Exactly as we have here in the schematic. Do you see? 1, 2, 3 are connected together. So this other pin should be connected together. 4 pins for drain should be connected together. So let's check in the motherboard. Let's put this probe in the first pin over here, okay, and check with this pin. We get a continuity, a bezel in the multimeter. So the 3rd pin also continuity bezel. The 4th pin, as you can see. So 4 pins connected together. This is the cathode. As you can see, we have this white mark here. Means this is the cathode. This part should be connected to these terminals here, and this part should be connected to the ground because this is a protection diode. So let's use the multimeter and check this diode. So we're gonna select, of course, the continuity option in the multimeter because we're gonna check the continuity. So as I told you, this is the anode. So the anode should be connected to the ground. As you can see in the multimeter, we have 0 reading in the multimeter and bezel means the anode connected to the ground. But for the cathode, it should be connected to main, to 90 volt power rail, to this red connector. So let's check. As you can see, how can we identify the type of this RAM? Easy. So we can just look here in the slot. Do you see here voltage? We have here 1.8 volts. Okay, we have 1.8 volt means this is DDR2 because the voltage for DDR2 is 1.8 volts. Okay, I will show you another motherboard. For example, this motherboard. So let's see the slot of this motherboard. As you can see over here, so as you can see, we have here 1.5 volt. The voltage for RAM in this motherboard means this is DDR3. Okay, so based on the voltage, we identify whether the RAM is DDR2, DDR1, DDR3, DDR4 or DDR5. So for example here, this is the schematic. This is the IC that powers the VTT for the RAM. So here we have the main voltage, as you can see, 1.8 volts. Okay, and over here we have 0.9 volts. So the voltage for the RAM and voltage for terminals. In this video, I'm going to teach you the right way to diagnose a failed motherboard. So if you look for how to repair and fix a dead motherboard, shorted motherboard, no power motherboard, or any failed motherboard, so this video is for you. So continue with me until the end of the video, and I guarantee for you that you will understand 100% how to diagnose any failed laptop motherboard. So let's get started. But first, don't forget to subscribe, share and like the video, because your likes motivate me to create more and more videos for you. And finally, I will create a Facebook group for you where I can assist and help you for free. So for any one of you that has any motherboard, field motherboard or laptop motherboard, you can join me on the Facebook group. I will create the Facebook group today and I will post the link of it in every videos in my channel, so you can join me and you can post any failure you have and I will help you with videos, images, suggestions, etc. until you fix your computer. So let's get started. So here, as you can see, basically we have two motherboards. Okay, so of course we're gonna use the multimeter in this video. We're gonna use the multimeter, and of course I will explain to you some stuff also in the schematic. For example, what is the MOSFET, for example, how to trace voltage, etc., component, etc. Okay, so basically here, as you can see, I have two motherboards. This is basically a very advanced and improved motherboard, okay, where we have this processor that integrate three chipsets: the processor, the graphic card and the NOR bridge. And of course we have another motherboard, old motherboard and new motherboard. So I'm going to teach you how to diagnose both, okay, in order to make the video a complete video. Okay, so let's begin first, for example, with this motherboard. First, this is basically a normal motherboard where we have, as you can see, so the processor, okay, this is the processor under this heatsink. So this is basically the heatsink, and here, as you can see, we have the NOR bridge, as you can see, and here we have the ICH. So for the graphic card basically is integrated with this NOR bridge, as you can see. Okay, so I'm going to teach you how to diagnose this motherboard, but first let's take a look to component of this motherboard. Okay, so processor, NOR bridge integrated with the graphic card. We have the ICH or SOOT bridge. Okay, so this is the memories, as you can see, the random access memory. Basically the type of this memory, as you can see. How can I have a question right now, how can we identify the type of this RAM? Easy. So you can just look here in the slot. Do you see here voltage? We have here 1.8 volts. Okay, we have 1.8 volt, means this is DDR2, because the voltage for DDR2 is 1.8 volts. Okay, I will show you another motherboard, for example this motherboard. So let's see the slot of this motherboard, as you can see over here. So as you can see, we have here 1.5 volt. The voltage for RAM in this motherboard means this is DDR3. Okay, so based on the voltage we identify whether the RAM is DDR2, DDR1, DDR3, DDR4 or DDR5. So you're gonna see right now in the screen the RAM, the type of RAMs and its voltages. And of course don't forget that every RAM basically has two kind of voltage. Okay, the main voltage, okay, and the voltage for terminals, we called it VTT, voltage for terminals. Okay, for example, for DDR2 the main voltage is 1.8 volts and the VTT is 0.9 volt. I will show you in the schematic. So for example here, this is the schematic, this is the IC that power the VTT for the RAM. So here we have the main voltage, as you can see, 1.8 volts. Okay, and over here we have 0.9 volt. So the voltage for the RAM and voltage for terminals I will show you in the motherboard. So basically the main voltage is for the RAM, okay, the RAM chipsets, and the VTT is for terminals. Do you see terminals? Here we have terminals. Okay, this is basically terminals. I told you that first we're gonna see the components. So we have seen the processor, the NOR bridge, the ICH, the RAM. Okay, then as you can see here we have CMOS battery, Okay, we have the card, network cards. Okay, this component like this are inductors or coils. Okay, here we have basically ICs. Do you see? This is basically ICs. So this is electrolytic capacitor. This is capacitors. Here we have the BIOS. Do you see the BIOS? Always the BIOS is marked with a paint, as you can see. As you can see also for this motherboard, you see? Here we have a paint for the BIOS. So always the BIOS is marked with this paint. But of course in some motherboard it could not be marked with a paint. Okay, so we have the BIOS, as you can see. We have this, we call this tantalum capacitor. Do you see? This is basically tantalum capacitor. This one, this two also, and this one also is tantalum capacitor. For tantalum capacitor, basically it has many colors. So those also, as you can see, are tantalum capacitor. So you can find it also in this color, as you can see, the white color. Okay, as you can see also this black color. So for tantalum capacitor, it is a polarized capacitor where you find this part. This is positive terminal and negative terminal. Okay, as you can see, for example, here we have plus. So positive terminal and negative terminal. Basically this capacitor are used to filter the voltage. The same working principle as electrolytic capacitor like this one. Okay, so then as you can see here we have ceramic capacitor. This is basically ceramic capacitors. Okay, and we have here Zener diode. As you can see, this is Zener diode. Here we have the cathode and here we have the anode. This is basically transistor. Here we have MOSFETs. This is 8-pin MOSFETs. So in the motherboard you can find this kind of MOSFETs, 8-pin MOSFETs, where you find 4 pins for drain, 3 pins for source, and the 4th pin is for gate. Okay, or even you can find this kind also of MOSFET, as you can see, with 3 terminal MOSFETs. So this is 3 terminal MOSFETs. So basically here we have the source, drain, and gate. And we have 8 terminal MOSFETs, as you can see. So for example, to identify the first pin, we have this dot here. Do you see this white dot? Means this is the pin number 1, pin number 2, pin number 3. So these 3 pins are source. The pin number 4 is gate, and the 4 other pins are for drain. I will show this in the schematic. So as you can see here in the schematic, do you see? Here we have pin number 1, 2 and 3. So these 3 pins are connected together. So this is the source. Do you see S? And here we have the 4th pin is gate. Here we have J means gate, as you can see. So the gate always is connected to an IC, a control IC, as you can see. So the gate for this MOSFET is connected to this IC, as you can see. Do you see the gate here? Here we have drive. DL means drive low. Okay, because here this MOSFET is lower, but this one, the gate, if this one, for example, if we follow it, we're gonna find DH means drive high. The higher MOSFET, the lower MOSFET. Okay, so 3 pins for source, the 4th pin is for drain, and the other 4 pins are for gate, and the other 4 pins are for drain. We can even check the MOSFET using the multimeter. Okay, so let's check using the multimeter. So to check the MOSFET using the multimeter, we should always select the diode option. Okay, the diode option, as you can see. Why? Because simply the MOSFET contains diode inside it. As you can see, this is MOSFET. Here we have the diode. Do you see the diode? Between drain and source. That's why we put the multimeter to the diode option. Let's power on the multimeter. Okay, so the multimeter is set to the diode option, as you can see. So here, for example, let's take this MOSFET. Do you see the white dot here? Means this is the pin number 1. Means this pin number 1, 2, 3 are source. We should find a continuity here. So let's check. I will put one probe here in the pin number 1 and the other probe in the pin number 2. We get a continuity in the multimeter and a bezel. So let's check the other pin. The 3rd one, we get a continuity. So the 4th one, nothing in the multimeter. We didn't get a continuity because this is the gate. So these 3 pins are connected together. So this is source. So please, by the way, here I put the multimeter in the diode option, but of course to check the continuity we should of course select the continuity option, the buzzer. But for me in this multimeter the diode option and the continuity option is in the same place. Okay, so here we check the MOSFET. Here we find 3 pins connected together exactly as we have here in the schematic. Do you see 1, 2, 3 are connected together? The 4th pin is not. This is the gate. So this other pin should be connected together. 4 pins for drain should be connected together. So let's check in the motherboard. So this is the drain. Okay, so here we have the white dot, means 1, 2, 3. This is source. The 4th pin is gate. These 4 pins should be drain, should be connected together. So let's check using the multimeter. Of course, always the continuity option, and let's put this probe in the 1st pin over here. Okay, and check with this pin. We get a continuity, a buzzer in the multimeter. So the 3rd pin also continuity buzzer. The 4th pin, as you can see. So 4 pins connected together, exactly as we see in the schematic. Okay, now you understand the MOSFET. So good. Now let's diagnose the motherboard. So if you get any motherboard from any customer, what should you do first? The first thing to do, please pay attention, is not using the multimeter checking the motherboard. No, the first thing to do is the visual inspection using just your eyes. Okay, you know, really about 60% of motherboards I get from customers, I find the issue and the problem using just my eyes, just the visual inspection. Because using the visual inspection you can spot and identify the failed component without making any measurement. Okay, that's why you should always use a visual inspection. I will show you a proof. For example, for this motherboard, for example, if you do a visual inspection, you can find, as you can see, like this IC. Do you see? Do you see this hole? This is a blown IC. Okay, so this is a blown IC. So using just your eyes, the visual inspection, you can spot the problem. So now I can just replace this IC and fix the problem. Of course, it can be another component around it, but you should always do a visual inspection. Okay? After that, what should you do? If you have, for example, if you get a shorted motherboard or no power motherboard or a dead motherboard, please, the second step is what after the visual inspection is what? Is it to use the multimeter? No. Check the connectors. Check the connectors. You can find a shorted connector, a bad connector. So by checking the connectors, you can find a damaged connector or a connector that is shorted inside it. So I will show you an example. For example, this connector. Do you see this connector? This USB connector. Basically, the USB connector contains inside it 4 pins. But for this one, for example, do you see these 2 pins are touching others? Means here we have a short circuit. So this motherboard is just for training. So this is a very exclusive information. I'm sure that you will not find this kind of videos anywhere in YouTube or in the internet. This is a very exclusive information. So the first thing is doing visual inspection. The second thing is checking connectors, because also about 25 until 30% of failed motherboards due to connectors, shorted connectors. Of course, all connectors, of course, not just USB connectors, but all connectors, including, for example, RJ45 connector. So as you can see, RJ45 connector could be also shorted connector, okay, etc. So please don't forget this step. So the first step, visual inspection. The second step, connections. Okay. So then the third step, if you want to diagnose a failed motherboard, a no power motherboard, a dead motherboard, a shorted motherboard, is what? Is by checking the power jack or the DC jack, as you can see over here. This is basically the DC jack. Do you see the DC jack? This is the third step. Why exactly the third step? Because here we have the voltage input. This is the input voltage. So this power jack also could be shorted power jack. That's why you should look inside it and see if the negative probe touch the positive probe or not. And of course you can find the second failure of the power jack is a dry power jack. What does mean a dry power jack? A dry power jack means when this, as you can see, the terminals of power jack are dry, are removed. So it means there is no connection between this terminals and the motherboard. This is why I mean with dry connections. Dry connections or dry soldering is one of the most common fault on dead laptop motherboards. Then what is the next step? In the fourth step, we gonna use the multimeter. So we gonna use the multimeter and look for the main voltage. So for example, you can pick here the ground everywhere here in the motherboard and put the black probe in the motherboard, and you can just connect the adapter here and check for the 19 volt in the fuse. Okay, in the first component around the power jack, for example, the inductor or fuse. If you find the 19 volt here, for this motherboard, you should check, for example, this component. This is basically an inductor. You should find 19 volt here. But for this motherboard, for example, this is the power jack. Here we have the connector for the power jack. You should check this MOSFET. You should find basically 19 volt here in the source of this MOSFET. Okay. For this motherboard, for example, this is a power jack with cable. You should find here a 19 volt in the read terminal. Do you see a read terminal? So the fourth step is to check the read terminals here. You should get 19 volt, and also in these switches you should get 19 volt, and also in the cathode of this diode. Okay, this is basically a protection diode. So the anode of the diode is connected to the ground and the cathode connected to main volt. This is a protection diode. I can even use the multimeter and check what I'm seeing here. So this is the cathode. As you can see, we have this white mark here, means this is the cathode. This part should be connected to these terminals here, and this part should be connected to the ground because this is a protection diode. So let's use the multimeter and check this diode. So we're gonna select, of course, the continuity option in the multimeter because we're gonna check the continuity. So as I told you, this is the anode. So the anode should be connected to the ground. As you can see in the multimeter, we have 0 reading in the multimeter, and buzzer means the anode connected to the ground. But for the cathode, it should be connected to main, to 19 volt power rail, to this red connector. So let's check. As you can see, okay, that's why we call this diode protection diode. I will show you in the schematic. So do you see exactly like this diode, as you can see? So the anode is connected to the ground and the cathode is connected to power rail. Basically here I don't have 19 volt, but the same as this one. The anode connected to the ground and the cathode connected to the power rail. This is basically protection diode. So the fourth step is by checking the power jack. So after the power jack, of course, so do you see here the DC jack? So after the power jack, we're gonna continue and checking the component that exists in the main power rails, as you can see. Do you see this line? This is basically a bolded line. This line means a high voltage. This is a high voltage, and this lines or path like this means a low voltage. So here, for example, do you see here? So high power trace. This line means high power trace means 19 volts. This is basically the main voltage, but of course in some motherboards you can find 18 volts, 18.5 volts, 16 volts, etc. But the main voltage is usually 19 volts. So that's it guys for this video. This is basically part 1. In part 2 I'm going to continue by troubleshooting this trace, as you can see, of course using the schematic, the motherboard and the multimeter. Okay, I don't want to make a very long video. The second part, the part number 2, when we're gonna continue discussing how to diagnose a laptop motherboards. And don't forget, this is just the first motherboard. The motherboard, as you can see, that is old motherboard. We're gonna also troubleshoot and study this motherboard. This is a very improved motherboard using the same working principle. So I think that this course will contain 3 parts. So this is the first part. This is a very important course. Please don't miss this course, and please don't forget to subscribe if not already subscribed. Share the video with other people like you, and please don't forget to like the video, because your likes really motivate me to create like this video for you. So thank you very much, and see you in the next video. And don't forget, I will create today a Facebook group, and I will inform you with the link of the Facebook group where you can post any problem you have with your motherboards and laptops, and I will assist you. So every single day I will be here in the Facebook group, and I will assist you until you fix your problem. So please share the video, like and subscribe. Thank you very much.